Physics Notes, State of Matter by Iasstudy Group. So let's talk about state of matter. In physics, a state of matter corresponds to a degree of consistency of the material, density, crystal structure, refractive index, that results in behaviors defined by the laws of physics, malleability, ductility, viscosity, law perfect gas, etc. The different states of matter. The three most classical states of matter are, the state gas, state liquid, state solid. This classification is incomplete, however. We can add various more exotic states, the plasma, ionized gas, state supercritical, indistinction gas liquid obtained by increasing the pressure, state mesomorph of liquid crystal intermediate between liquid and solid, the Bose-Einstein condensate, condensation bosons in the lowest energy level, for example, the superfluid condensate or rubidium, see laser cooling of atoms, state supersolid whose existence is controversial. Metals. John Teller, state in which a material is both insulating and superconducting. But the behavior of matter are not always uniform within the same state. Thus there exists the intermediate states where a solid is observed to behave like a fluid, powdery or granular material, or on the contrary a liquid having certain properties specific to solid. These behaviors can result from more or less intimate mixtures of several phases, called polyphasic states. We can also meet the material in a non-equilibrium state, then the material properties depend on time because the material is relaxed, never reaching thermodynamic equilibrium. All spatially heterogeneous material will fall within this definition since these spatial heterogeneity will result in internal stresses and involving a thermodynamically unstable state. However, such systems' relaxation time can reach such long periods that they are experimentally unobservable, up to several tens of thousands of years. Classical states of matter across macroscopic, solid, has a volume clean, it is very difficult compressible, volume hardly depends on the temperature effect by thermal expansion, generally low, has a shape, but it can be deformed under the effect of stresses, according to its elasticity and its ductility. In the solid state, the particles, atoms, molecules, or ions, are bonded to each other by chemical bonds that secure their relative positions. Liquid at the macroscopic scale, liquid, has its own volume, does not have own form, it takes the form of the container thereof, has a free surface to rest planar and horizontal, in a uniform gravitational field. In liquid form, the particles are loosely bound, in contrast to the solid state, they can spontaneously move relative to each other, deformability, but unlike the gaseous state, they are not independent, incompressibility. One can also say that their thermal energy is sufficient to allow them to move but not escape. The liquid state is a fluid, that is to say perfectly deformable. Gaseous state at the macroscopic scale, a gas, has neither own form nor own volume, tends to occupy all the available volume. As a gas, the particles are very weakly bound, virtually independent. It is considered independent in the model of ideal gas, that describes the behavior of low gas pressure. As the liquid, a gas is a fluid state. A body in the gaseous state consists only of atoms and molecules. An ionized gas is called plasma.